It is generally permissible to run a number 2 wire to a subpanel inside a wall, even if the subpanel is approximately 15 feet away. The key considerations are proper wire sizing, appropriate overcurrent protection, and adherence to all relevant electrical codes. It is not typically required to run the wire on the outside of the building in this scenario, assuming all code requirements are met for indoor wiring. Let's delve deeper into the specifics to ensure a safe and compliant installation. Firstly, wire sizing is paramount. The number 2 wire must be capable of carrying the anticipated load of the subpanel without overheating. Consult the National Electrical Code, or NEC, Table 310.16 to determine the ampacity of the number 2 wire based on its insulation type, temperature rating, and the ambient temperature where it will be installed. Copper and aluminum conductors have different ampacity ratings, so be certain you know the conductor material. Secondly, overcurrent protection is crucial. The circuit supplying the subpanel must be protected by a circuit breaker or fuses sized appropriately for the ampacity of the number 2 wire. This overcurrent device protects the wire from overload and short circuit conditions. The size of the circuit breaker or fuses should not exceed the ampacity of the wire, as specified in NEC Table 310.16 and further adjusted per NEC 240.4. Thirdly, consider the wiring method. The number 2 wire can be installed using various wiring methods such as conduit, cable, or direct burial depending on the application and local codes. For indoor installations within walls, non-metallic sheathed cable such as type NMB or conduit with individual conductors are common choices. If using cable, ensure it is listed for the intended use and is installed in accordance with NEC Article 334. If using conduit, select the appropriate type for the environment such as ENT or PVC and comply with NEC Chapter 3 regarding conduit fill and support requirements. Fourthly, pay attention to box fill calculations. When terminating the number 2 wire at the main panel and the subpanel, ensure that the boxes are sized appropriately to accommodate the conductors, connectors, and any devices installed within the box. NEC Article 314 provides detailed requirements for box fill calculations based on the number and size of conductors, device yokes, and internal clamps. Overfilling a box can lead to overheating and potential fire hazards. Fifthly, grounding and bonding are critical for safety. The subpanel must be properly grounded to the main panel to provide a low impedance path for fault current. This grounding conductor helps to trip the circuit breaker in the event of a ground fault, minimizing the risk of electric shock. Typically, a separate equipment grounding conductor, such as a green or bare wire, is run with circuit conductors to the subpanel and connected to the grounding busbar in both panels. Additionally, all metallic enclosures, such as the subpanel enclosure and any metal conduits, must be bonded together to create an effective ground fault current path. Sixthly, consider the environment. If the wiring is exposed to moisture, corrosive substances, or physical damage, select wiring methods and materials that are suitable for the environment. For example, if the wiring is installed in a damp location, use moisture-resistant cable or conduit and fittings. If the wiring is subject to physical damage, protect it with conduit or other suitable means. Seventhly, comply with all applicable codes and regulations. Electrical codes vary depending on the location, so it is essential to consult the local electrical code and any applicable regulations before starting any electrical work. The NEC is a widely adopted standard, but local codes may have additional requirements or amendments. Eighthly, consider voltage drop. For long runs of wire, voltage drop can become a concern. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the wire. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, select a wire size that is large enough to carry the load current without excessive voltage drop. The NEC provides guidelines for calculating voltage drop in NEC 210.19 and 215.2. Ninthly, proper connections are crucial. Ensure that all connections are made using approved connectors and are tightened to the manufacturer's specifications. Loose or corroded connections can cause overheating, voltage drop, and potential fire hazards. Use a torque wrench to tighten connections to the specified torque to ensure a secure and reliable connection. 10thly, labeling is essential. Label the subpanel and all circuits clearly to identify the loads they serve. This will make it easier to troubleshoot problems and perform maintenance in the future. Use a permanent marker or label maker to create clear and legible labels. The NEC requires specific labeling for subpanels and circuits as outlined in NEC 408.4. In summary, running a number 2 wire to a subpanel inside a wall is generally permissible if the wire is properly sized, protected by an appropriate circuit breaker, installed using an approved wiring method, and grounded and bonded correctly. Compliance with all applicable codes and regulations is essential to ensure a safe and reliable installation. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Remember to consult the National Electrical Code, specifically articles related to opacity, overcurrent protection, wiring methods, grounding, and bonding. Understanding the code requirements and adhering to best practices will ensure safe and compliant electrical installation. Furthermore, consider the specific application and environment where the wire will be installed. Factors such as ambient temperature, moisture, and exposure to chemicals can affect the performance and longevity of the wiring. Select wiring materials and methods that are suitable for the intended use and environment. If the subpanel is serving a critical load, such as life safety equipment, consider using a high-quality wire and wiring method to ensure reliability. For example, using a premium-grade cable with enhanced insulation and shielding can provide added protection against electrical noise and interference. In addition to the NEC, local codes and regulations may have specific requirements for electrical installations. It is essential to consult with the local authorities to ensure that the installation complies with all applicable codes. Some jurisdictions may require permits and inspections for electrical work. Obtaining the necessary permits and inspections can help to ensure that the installation is safe and compliant. When selecting a circuit breaker for the subpanel, choose a breaker that is compatible with the panel and is listed for the intended use. Circuit breakers are available in various types, such as standard thermal magnetic breakers, ground fault circuit interrupter, or GFCI breakers, and arc fault circuit interrupter, or FSI breakers. Select the appropriate type of breaker based on the application and the requirements of the electrical code. GFCI breakers are required in areas where there is a risk of electric shock, such as bathrooms and kitchens. FSI breakers are required in bedrooms and other areas to protect against arc faults, which can cause fires. When installing the number 2 wire, avoid sharp bends or kinks in the wire. Sharp bends can damage the insulation and reduce the ampacity of the wire. Use conduit sweeps or bending tools to create smooth, gradual bends in the wire. When pulling the wire through conduit, use a wire lubricant to reduce friction and prevent damage to the insulation. Use the proper size and type of connectors for terminating the number 2 wire at the main panel and the subpanel. Use connectors that are listed for use with the type of wire being used. Tighten the connectors to the manufacturer's specifications to ensure a secure and reliable connection. After completing the installation, test the subpanel and all circuits to verify that they are working properly. Use a multimeter to check the voltage and current on each circuit. Test the circuit breakers to ensure that they trip properly in the event of an overload or short circuit. Label the subpanel and all circuits clearly to identify the loads they serve. Use a permanent marker or label maker to create clear and legible labels. Proper labeling will make it easier to troubleshoot problems and perform maintenance in the future. Keep a record of the installation, including the wire size, circuit breaker size, wiring method, and grounding and bonding details. This record will be helpful for future maintenance and troubleshooting. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation. Electrical work can be dangerous, and it is important to take precautions to avoid electric shock and fire hazards. A qualified electrician will have the knowledge, skills, and experience to perform the installation safely and correctly. Remember that working with electricity can be dangerous. Always de-energize the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. Furthermore, remember to document the entire process for future reference and maintenance. Create a detailed wiring diagram showing the location of the subpanel, the wire run, the circuit breaker size, and the grounding and bonding connections. Keep this diagram in a safe place where it can be easily accessed when needed. Consider adding surge protection to the subpanel to protect sensitive electronic equipment from voltage spikes. Surge protectors can be installed at the main panel or at the subpanel to provide protection against surges caused by lightning or other electrical disturbances. Periodically inspect the subpanel and wiring for any signs of damage or deterioration. Look for loose connections, corroded wires, or damaged insulation. If you find any problems, repair them promptly to prevent further damage or potential hazards. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. An electrician can provide expert advice and guidance to ensure that the installation is safe and compliant with all applicable codes and regulations. In addition to the technical aspects of the installation, consider the aesthetic appearance of the wiring. Run the wires neatly and securely, and avoid creating unnecessary clutter. Use cable ties or other fasteners to keep the wires organized and out of the way. By paying attention to both the technical and aesthetic aspects of the installation, you can create a safe, reliable, and visually appealing electrical system.